Hi class, welcome to a whole new chapter. We're on chapter 6 right now. Chapter 6 is all about quadratics. Another word for quadratics, the graph, is a parabola. So you guys have been introduced to this before, but now we're going to dive deeper into it as well. So we're on 6.1 through 6.3. We're graphing and solving quadratic equations. This video lesson is going to talk about graphing it, but it's also going to talk a lot about terminology, because there's a lot of terms in this chapter, and we need to make sure that we know what all these terms mean, so that we're speaking the exact same language so we can communicate with one another with these terms. So quadratic functions in standard form, it's written like this: y, or f of x, equals ax squared plus bx plus c. So all of these quadratic functions have an x squared. Okay, so that's very important. If you didn't have the x squared there and just had the bx plus c, that would be a linear function, not a quadratic. So that's why it says a cannot be 0. A has to be a number, because if a is 0, now it's not a quadratic anymore, it's just a linear function. It also says that x's must be in descending order, so make sure you have the squared term first, then you have x raised to the first power in the middle, and then you have your constant term last, that constant term c. Okay, so now that we know that the standard form is ax squared plus bx plus c, if a is positive, which means if a is greater than 0, then the parabola is going to open up. So that U shape is going to open up. It's going to look something like this. Okay, those are our parabolas. If a is greater than 0, or if a is positive, then I know that it's going to open up. If it opens up, then it has a minimum value. The maximum value doesn't exist because this goes all the way to positive infinity. Both of these do as far as the y-axis is concerned. So it doesn't have a maximum value, it's infinity. But the minimum value is at the very bottom of that U shape. It's at the vertex is what that's called. So where I put that green point right there, that's the minimum value. So we talk about the minimum value on the y-axis. So the minimum value here is like a negative 2.5 or something like that. There's our minimum value. Very similarly, but in the opposite way, if our a value is negative, if it's less than 0, so if this were a negative ax squared plus bx plus c, if that's negative, then the parabola opens down and it has a maximum value. So if this were a negative a value, it would look something like this. There's our parabola. It would have a maximum value. The highest point on this graph, once again, is at the vertex. It's something like right there. It wouldn't have a minimum value because these arrows go all the way down to negative infinity. But the maximum value it does have when the parabola opens down. And again, we talk about the y-axis when we talk about maximum values. So the maximum value would be the y value, which would be at like 3.1 or something like that. So those are a couple terms that we're going to need to know for this chapter. Some more terms here is how to find the axis of symmetry and what the axis of symmetry is. It's a vertical line that cuts the parabola in half. All of our parabolas are symmetrical, which means the right side is the exact same as the left side. So here's an example of a parabola. Here is an example of a parabola. And they're always symmetrical, which means if I were to draw the line of symmetry, if this were to be the line of symmetry, if I folded my parabola right on the line of symmetry, the right sides and the left sides would be the exact same. And the same is true of parabolas that open down. If I draw a line right here, this is a vertical line that cuts the parabola in half, which means that the right side is the exact same as the left side. If you were to fold that parabola on that green dotted line, the right sides and the left sides would land on top of each other. That's what symmetrical means, and all of our parabolas are symmetrical. To find this line right here, it's a vertical line, which means it's an x equals line. You take your b value and you take the opposite sign of it, so it's a negative b over 2 times whatever your a value is. So we're going to practice that 2 times today. In the numerator is a negative b, and the denominator is 2 times the a value. Once you get your axis of symmetry, you could then find the vertex. The vertex is always located on the axis of symmetry, because that's always where the highest or the lowest part of the parabola is. So to find the x-coordinate, this is an xy ordered pair. To find the x-coordinate, it is the axis of symmetry, so a negative b over 2a is the x-coordinate of our vertex, and then the y-coordinate you find by substituting. So once again, I'll tell you how to do that later on in our notes for today. But to find the vertex, so the vertex is the y value you get by substituting the axis of symmetry for the x value. So that's how we find the vertex. Okay, and then last thing here before we start getting into graphing is, in order to graph it, there's several things that we can do. One thing that students like is they like technology, so to use your graphing calculator, enter the equation and look at the graph. The table there on the graph really helps to find where your points are, so we're going to talk about that. We could also make an XY table and pick values. This works for any equation that we could do. We talk about this with linear functions, with quadratic functions, with polynomial functions. You could easily just pick values. Or one thing that I like the best is I like to memorize this pattern for A, because then it goes very, very quickly. And I'll show you how to do this in the notes for today. So whenever A is 1, we go up 1, right 1, up 3, right 1. If A is 2, up 2, right 1, up 6, right 1. When A is 3, we go up 3, right 1, up 9, right 1. And this would be the exact same thing if A was a negative number. If A was a negative number, now all of these ups would turn to downs, because now our parabola is open down when A is negative. So it would be down 1, right 1, down 3, right 1. Down 2, right 1, down 6, right 1. So all of those ups would turn to downs if our A was negative. Okay, so let's start talking about how to graph these. We have f of x equals x squared minus 6x plus 3. We know this is a quadratic because we have an x squared term. So whenever our degree is 2, or whenever our highest power of x is 2, we know it's going to be a parabola. So the very first step with graphing any parabola is to find the axis of symmetry. So the axis of symmetry is found by taking a negative b over 2a. So your a value here is 1. It's 1x squared. So this is our a value. Our b value is a negative 6. It's the term right in front of x, and our constant term c is the number 3. So a negative b over 2a is how we find our axis of symmetry. So a negative 6. Our b value is negative 6, so negative 6 is a positive 6. Over 2 times whatever our a value is, 2 times 1. 6 divided by 2, our axis of symmetry is the line x equals 3. Make sure you don't just put 3, put x equals 3, because if you just say 3, you're telling me a point. But if you say x equals 3, you're telling me a line. And the axis of symmetry is a line, x equals 3. Let's draw that on our graph. The axis of symmetry we always draw with a dotted line. So at x equals 3, which is right here, let's draw a dotted line on our graph. So this is going to be where our parabola is symmetrical about. Now that we have that, it says find the vertex, which means plug in the value from the axis of symmetry in for x and solve for y. So we're finding the vertex. So what is y when our axis of symmetry is 3? So put 3 in for all of these x's. So it's going to be 3 squared minus 6 times 3 plus 3. So then we get 9 minus 18 plus 3. 9 minus 18 is a negative 9, and a negative 9 plus 3 is a negative 6. So our y-coordinate is a negative 6. So when we write our vertex class, make sure we always write it as an ordered pair, because that's what our vertex is. It's an xy ordered pair. So our vertex is at the x-coordinate is the axis of symmetry, which we got to be 3. And the y-coordinate we found by substituting, which is a negative 6. So I'm just going to write that again. To find the vertex at any time, the vertex is the x-coordinate, a negative b over 2a, which is our axis of symmetry, and the y-coordinate you'd find by substituting. Let's put our vertex on our graph. So let's go right 3, down 6. Right 1, 2, 3, down 1, 2, 3, 4, 5, 6. And there is our vertex. So that's either going to be the lowest possible point or the highest possible point. If we look up here, our a value is a positive 1. If it's positive, our parabola is open up. If it's negative, our parabola is open down. So this parabola is going to open up. Now we're going to use this pattern for how we're going to graph the other points. So when a is 1, which in this case it is 1, we're going to go up 1, right 1 from our vertex. So from our vertex, go up 1, right 1, put a point. There it is. Now from this point, go up 3, right 1. So go up 1, 2, 3, right 1. And there's our other point. Okay? Parabolas are always symmetrical, so do the exact same thing on the left side of the axis of symmetry. Go up 1, left 1, up 1, 2, 3, left 1. And there is how we graph this parabola. I need to see those 5 points on your next chapter test, class. Those 5 points are, don't just sketch the parabola on what you think it looks like by using your calculator. I need to see all 5 of those points on our graph. So now let's talk about the minimum value. The minimum value is this vertex, but it's the y-coordinate. So here's how I want you to write the vertex. Here's how I want you to write the maximum or minimum value on your test. Right? There is a minimum of your y-coordinate is a -6. So a minimum of, or the minimum is a -6. And then I want you to write this, when x equals 3. So it's a minimum value of a -6 when x equals 3. That's how I want you to write your maximum minimums from here on out. So now lastly, we've got to talk about set and interval notation for the domain and the range. So for our domain, we talk about the values from left to right. So this blue line right here, this parabola rather, how far to the left does this arrow go? It goes infinitely to the left, does it not? Whoopsies. That was not good. Something like that. This blue line goes infinitely to the left. It also goes infinitely to the right. So our domain goes from -infinity to +infinity. It's all of the real numbers. So that's what our domain is going to be. In interval notation, that's where we use our parentheses. It's -infinity to +infinity. For our set notation, that's where we talk about x such that x. And when it's -infinity to +infinity, it belongs all of the real numbers. So most parabolas, at least the ones that open up and down, their domain is always -infinity to +infinity and all the real numbers, because they extend infinitely to the left and infinitely to the right. Our range isn't that case. Our range is different. So our range, we talk about going from bottom to top. So our lowest possible value is the y-coordinate of the axis of symmetry, or of the vertex, which was a -6. So we know that it starts at a -6, and then it goes to +infinity. These arrows go infinitely up. So it starts at the lowest possible point. That minimum value is a -6, and then it goes all the way to +infinity. So for interval notation, it starts at a -6. It includes -6, so we have a bracket at -6, and it extends all the way to +infinity. -6 to +infinity. So for our range, for set notation, we talk about y such that y, and if it's all of the numbers that are bigger than -6 or higher than -6, we say it's greater than or equal to a -6. A lot of stuff on one page here. We're going to practice it again, and hopefully then when you do your worksheet in your accelerated math, you can just follow these steps. So let's try it again here for problem number 2. Problem number 2 is a parabola because we see that we have an x squared. So whenever there's an x squared for our degree, it's going to be a parabola. Notice how it's a -x squared, so that means that the parabola is going to open down. But our first step is to find the axis of symmetry. So a -b over 2a. So the b value is a -4 over 2 times the a value. The a value is a -1. So a -4 divided by a -2 is a +2. So our axis of symmetry is the line x equals 2. Once again, don't just put 2, put x equals 2. I will dock you for that on your test if you don't have x equals. So x equals 2, let's draw a vertical line. There's our axis of symmetry. So our parabola is going to be symmetrical about that line. The vertex you find by substituting. So we get y equals, instead of a -x squared, it's a -2 squared plus 4 times 2 minus 1. So now simplifying this, 2 squared is 4, and 4 times a -1 is a -4. Plus 4 times 2, which is 8, minus 1. So -4 plus 8 is 4, and 4 minus 1 is 3. So our vertex is an ordered pair. It's when x is 2 and y is 3. Our vertex is at 2, 3. So let's put that on our graph. Right 2, up 1, 2, 3. Notice how our vertex is always on the axis of symmetry. That always happens. It lies on the axis of symmetry. So our A value now is a -1. So let's use our patterns for A. So when this is a -1, now all of these just turn to down. So down 1, right 1, down 3, right 1. So from our vertex, go down 1, right 1, and then from that point, go down 1, 2, 3, right 1. Same thing on the other side. They're always symmetrical. So now we draw our parabola going through those 5 points. Okay, let's define what our maximum or minimum is. When the parabola opens down, it's a minimum value. So the minimum is whatever the y-coordinate is. Maximum. It's a high point. There's a maximum when our graph opens down. I apologize for that, class. So it's a maximum of 3. The max is 3 when our x-coordinate is 2. So when x is 2, we have a high point. Our maximum is 3. Now we're going to talk about our set and interval notation again. These arrows go infinitely to the left and infinitely to the right. They just keep on going right, 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 right. It's slow, but it does continue to go right and left, 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 left. So that tells us that it goes from -infinity to +infinity. So there's my interval notation, -infinity all the way to +infinity. Which means we get x such that x belongs all of the real numbers. That's what we get for our set notation. So now for our range going from bottom to top, how low do these arrows go? Hopefully you see that they go infinitely down, infinitely, infinitely, infinitely. So it starts at -infinity. And we always have a parenthesis with -infinity. And how high does my parabola go? It goes as high as my maximum value does. It goes higher and higher and higher, and once it gets to my vertex, it starts going down again. So how high does my range go? It goes to a range value of +3. So it goes from -infinity, that's how low it starts, and it goes as high as 3. It includes 3, so I have a bracket there. So then for our set notation is y such that y is all of the numbers that are below 3 or less than 3, which means less than or equal to 3. There is a lot of the terminology and how to graph them. Let me know if you have any questions on that when you get to class tomorrow.